Hey, welcome to this video. Today we will be discussing the four basic principles, otherwise known as pillars, of object-oriented programming, more specifically oriented to C#. So these are specifically the abstraction, encapsulation, inheritance, and polymorphism. We will go and watch that in code as now. Okay, so let's first talk abstraction. Abstraction is, well, the whole point of abstraction is we will try and get only the most important characteristics of an object, say anything you can find in real life. We will try and replicate it with code, but only keep the most important characteristics. Anything that is not that important, you will probably be able to implement it later through some other characteristics that we will see afterwards. So first, the abstraction can be done in C# with two different types of elements, either an abstract class or an interface. In this case, let's use an interface, which we will call iVehicle. We will talk about vehicles in this video, which is a very classic example. So we're creating our interface, and you will notice first that I named it with an I at the beginning of the name. So that's a very popular convention which dictates that you will put an I in the beginning of an interface name because it's an interface, so that's the notation. So we will think about what's common to every vehicle, say a rocket, say an airplane, say a boat, a car, a bicycle. What do they all have in common so that we can actually abstract what a vehicle is and what are its states and what are its behaviors. So just to make it short, let's think of a brand. Normally, a vehicle has a brand, no matter what it is. So we will notice that an interface cannot have fields of its own. So if I say string brand semicolon, you will notice it will point out there's an error, and it says interfaces cannot contain instance fields. It cannot have fields. However, if I change it to a property, which will be in this case just a matter of syntax, but then again, a property has a whole different way to work, then you will have no errors because interfaces can have properties. Now, let's talk behaviors, say methods. So public void, well, you can start any vehicle. So start. And also you can, of course, stop it. So it's public void stop. So IntelliSense is allowing me to do anything with just a couple of tabs. Good. So we do have the whole concept of a vehicle in an interface. So we have its brand, we have the possibility to start it, and we can stop it. So in that case, as an idea, we do have what a vehicle is and what it is about. There we have everything we need. In the next point, we will talk about inheritance. So we're talking inheritance here. And then we will create a couple of classes that will allow us to do inheritance. So first, we will implement this interface we created. So I will create the class car, which will implement a vehicle. So it will point an error. Why? It says it hasn't implemented the member called brand. So first things first, we need to have public string brand get set. There we go. So we do have our reference, and if we click here, you will notice it will point you to the interface we created before. Line 11, it says. So now for the methods, let's say void start. So we will simply write something into console. Console point right line. Sorry, Spanish slip. Let's say just broom, broom. Just any sound the car might make. So let's do the stop method and say public void stop. It will not receive any parameters, and then we will just say console dot write line. The car has stopped. Semicolon. Okay, so we do have our car which implements the iVehicle interface, but we need to add something that will actually inherit that. So we do have our car. Let's now create our race car, just for excitement. So we do have our race car class, and we will say it will inherit car. There we go. So saying car, we have the brand, start, and stop. So we will have an accelerate method. We'll say public void accelerate. It won't receive any parameters. And first, before accelerating our car, of course we need to turn it on. Say we need to start it. So first we will have to say this dot up dot start parentheses, and you will see there are no errors. Why is that? It's because it has inherited the car class, so it has its own start, which will do exactly the same as in car. Very good. So now we will add some functionality to it. For educational purposes, we'll simply say, okay, accelerate speed to its max, and an exclamation point just for for being thrilled. Good. We have inherited already. So there's the next point we will talk about is encapsulation. Okay, our next point is encapsulation. So there are certain aspects of our classes that might only be accessible to some actors. So for example, let's say, since we have a race car, we will have a driver. So say private string driver. And let's make it a property. Missing an S. There we go. So you see the driver is private. So if we go program and say race car RC equals new race car, if we type rc.d, you won't find the driver as an option. That's because the driver is private, so nobody outside the class has access to it. So let's say print, oh, there we will have a method called public string print report. And then we will say, and this will be mostly for educational purposes, we'll create a string called result, which will be equal to blank string. Result will be equal to the driver is, and we will concatenate the driver's name. And then we will return result. Oh. There we go. So again, this is for educational purposes. The best practice would be to simply return all of this. So say return that. Have a line like this. But again, for educational purposes, we will stay like this for the time being. With this, we do have access to the driver somehow. Also, if we want to assign a name to that driver, we will say public race car, which will be our constructor, and we will say this dot driver, because we're in the same exact class, we will say it will be equals to, say, Mario, say my name. With this, whenever I print the report, it will tell the driver is Mario. Eventually, we can modify its name, but through some other method. But that's encapsulation. With this, only the same class will have access to the name of the driver. Nobody from the outside who shouldn't have access to it will be able to modify that. And that's the concept of encapsulation. Only those who should have access to an aspect of our class will have access. That's it. Let's now talk polymorphism. And last but not least, let's talk about polymorphism. So polymorphism has two branches. There's overloading and overriding. So for overloading, let's talk about our print report method. So overloading is having the same name of a method, but different signature. What's this about? So let's change our code. And here we will say public string print report. So you will see it's underlined, and it will say there are two errors. First, there's already a print report method with the same parameters, say same signature, and it's not returning anything. So two errors. First, let's address the parameters thing. So since we're just doing an educational video, let's do int max speed, and then int average speed. Okay, we do have now a different signature. It's receiving two parameters, so it's not the same method. The only thing here is that it's still not returning anything, and that's why it's giving us an error. So let's do again string result equals. Again, this is a very bad practice, but this is an educational purpose video, so that's why we're using this. So we will say that result equals the driver is plus driver. We're doing concatenation here, and then comma the max and average speeds were say we were in a race, and then let's do max speed. Oh, sorry, I'm missing the plus sign, which is concatenation. Max speed that to string, and then we will add a hyphen to separate. Don't forget concatenation, and then average speed point to string. And finally, to avoid errors, we will return result. And we will see how nothing is going on as of errors. And we do have two print report methods which function differently because of the parameters they get. Again, as you develop in your career, you will notice that not necessarily it's a matter of receiving two parameters and everything will change. Probably the changes will be smaller than this. Probably the changes can be bigger than this. It really depends on the project. But the thing is that you need to know that you can define two methods with the same name but different signature. Even I could have a third method that would have int max speed and say float average speed, and that's a whole other method, even though it's pretty similar. Now, if we go to program.cs and we use rc point print report and we open parentheses, you will notice that probably you won't see it in the video because of the technology I'm using, which is OBS Studio. But in Visual Studio, the IntelliSense will tell you there are two definitions to this method. There's the one that has no parameters in it, and if you click arrow down, you will receive the print report that has two parameters coming in. So that way you know there are two definitions to it. Now, that's overloading. What about overriding? Let's do overriding. Let's go to car. In order to override a method, we need it to be abstract or virtual. Say, since that line that says broom broom, it's pretty lame, let's change it for something virtual. Okay, we have a virtual method, and in race car, we will go and say public override void start. And it will tell us immediately if you use the IntelliSense base.start. That means let's do the same thing the base class does. So this is the start method from from car. I don't want it to do the same. So instead, we will do console point right line. And let's say the car has been started, period. Very serious. So now we do have two methods named start, which do different things. And the override keyword will differentiate them. And you see, in accelerate, we do have this point start. If we wanted to use the method that comes from the car class, we will use instead base point start. In that case, we will do whatever car does. But if we want to use race car, we'll switch to this dot start. With that, we will have overridden one of our methods. And well, pretty much that's how the 4 pillars of object-oriented programming work. I hope this was helpful. I hope this might give you a hand in a future interview or at least in your career. Have a good day. Remember, program and live your life.